I wanted to kind of study more of the molecular ways that spatial learning and memory works in honeybees. What I decided to do is to design a new test. So what I did is I took a look at the mammalian literature, like for rats and for monkeys. And a lot of the way they test learning and memory is through a food reward. So you put a rat in an arena, and there's a bunch of holes, and some of them have food, and the rat has to find its way to find the correct hole with the food. So I thought about it, and I basically did the same thing for the bees. So I put them in an arena, I put 4 artificial flowers, and only one of the flowers has sugar on it. The other ones are dry, there's nothing on it. And I let the bee into the arena. She takes her time, she finds the flower, she eats from it, and then I take her out of the arena. I do this a couple more times, so a few times so she remembers where this flower is. And then at the end, I do a memory test where I let her into the arena. There's 4 flowers, but now none of them have sugar. So they're all dry. And what we found is that the bees take less time to find the focal flower, the one that has sugar on it, as time goes on. And in the memory test, they go to that focal flower more often than not. We tested foragers and nurses. So when a worker bee begins her life in the hive, first 2 weeks of her life, she's a nurse. So she stays inside the hive and she feeds the young larva. Then as she matures, she becomes a forager. We know that when this transition happens, there's an area of the insect brain called the mushroom body that practically doubles in size, and that's the area responsible for learning and memory in insects. So I wanted to compare the learning and memory of nurses versus foragers, and we found that they learn at the same rate, but foragers have better memory.